Okay, Year 7, this is the last little thing that I just wanted to go through with you. We've looked at how we can use Pythagoras' theorem to find the hypotenuse of a triangle. But actually, Pythagoras' theorem will help us to find any side of the triangle. If you think about what we know, what we showed when we made the squares the other week, we showed that the sum of the squares on the two smaller sides equals the square on the largest side. Okay, so in this triangle, one short side squared plus the other short side squared equals the hypotenuse squared. Okay, but what you know about numbers, if two numbers add together to give a third number, then one of those numbers is the total minus the other number. So in this case, a squared plus b squared needs to be equal to c squared, but then a squared must be equal to c squared take away b squared. Okay, you could play around with some numbers and just check for yourself that you agree that that would be true. So for our right angled triangle here, a squared must be equal to c squared minus b squared. Remember, c is always the hypotenuse. So this is the side that I don't know, I've called it a. My other short side is called b, and my hypotenuse is called c. So I've identified that because here's the right angle. This is the side that's opposite the right angle, and it's the longest side in my triangle. Okay, I've written down the formula. That's my next step. The next step is to substitute or replace those pronumerals with the actual values. So here the actual value of the hypotenuse was 17, and the value of one of the shorter sides is 14. So I get that a squared equals 17 squared minus 14 squared. Now I'm at the point where I use my calculator. So work out those values. It's 289 minus 196, and that gives me 93. Remember, this is the square of that shorter side. So to actually find the length of the shorter side, I have to take the square root of 93, which I do on my calculator, and it gives me an answer. It actually gives me the answer 9.643650761. Okay, but I'll normally round that off to 1 or 2 decimal places. So always be careful to check what the question asks you to do and whether it says how many decimal places. Also, at the moment with this question, I haven't really told you what units I'm talking about, whether they're millimeters or centimeters or meters. That's not important for the calculation, but it will be important for you reporting your answer, especially once you're doing questions that come from real life contexts. Anyway, I hope that gives you an example of how you're going to use Pythagoras' theorem when it's one of the shorter sides that you don't know. That's basically all the things that we need to be able to do with Pythagoras' theorem. From here, we're just going to look at applications, how to use it when we have composite shapes, how to use it when we find right-angled triangles in 3D shapes, how to use it when we find right-angled triangles on a number plane. Okay, and I hope some of you will even look at how you can find the distance between 2 points using Pythagoras' theorem. Good luck with all you do.